Good day, everyone. And first of all, I'm stepping in for Stephanie Bullock, the Victorian chapter president, because there are technical issues with her joining the actual event. Hopefully, she can join us during the event and then do the emceeing at the end. But I will do the introduction on her behalf. So, on behalf of the Victorian team of the Institute of Architects, I'd like to offer you a warm welcome to today's lean-in session, the Australian Institute of Architects Decarbonisation Plan 2025 to 2050, Driving Climate Action. So my name is not Stephanie Bullock. I'm Stefan Preuss. I'm the Associate Government Architect. Stephanie herself is from Kozlov Architecture and the President, as I said, of the Victorian chapter. I'm the Associate Government Architect and will do the intro and then the first part of the presentation. It is my honor to do so as your host and moderator by the looks of it for this session. We're joining from across country today. I'm on Wurundjeri country myself, and so is the Institute here in Victoria, and we acknowledge with deep respect the traditional owners of this land. We acknowledge that it is a privilege to stand on country and walk in the footsteps of those before us, and we pay our respects to elders past, present, and emerging. This lean-in session is being recorded, so if you or any of your colleagues miss anything today or have to leave early, we'll be publishing this recording on the Institute's YouTube channel in the next couple of days, and we'll share that link with you in our opening email communications. I should say, just this is my own note, that it was very important to us to make this available for free to everyone because we think this issue is important. This lean-in session enables you to ask questions of our panelists. So if you have any question or comment, please use our Q&A box down below to add yours in, and we'll go through those later in the session. The session itself explores the architecture industry decarbonisation plan, as we said, developed by the Australian Institute of Architects and authored by the NCASC, which is the National Climate Action and Sustainability Committee, which I co-chair, along with Caroline Pitcock. It outlines 5 priority actions across regulation, measurement, procurement, finance, and education, offering a coordinated roadmap to net zero. It outlines how the profession can lead Australia's built environment transition through policy, advocacy, and practice. We have 3 presenters in this session. Myself, as I said, Associate Victorian Government Architect and co-chair of the committee. I also co-authored the document. I'm a passionate expert and advocate for the sustainable built environment. I also sit on the NABERS National Steering Committee, and we'll come to NABERS a bit later. After I do the first part, the advocacy part of the plan, we'll be hearing from Alison Potter, who is a design principal at HDR with over 20 years of project experience locally and globally within internationally recognized design practices. That includes Grimshaw and Fosters and Partners, who of course everyone should know about. She brings a global and sector-diverse perspective to regenerative and decarbonisation-focused design and contributes to national climate leadership through the NCASC committee. And finally, we'll be joined by Alex Morrison from Wardle, who is a senior architect and sustainability leader at the practice. With nearly 20 years experience, she champions low-carbon design through award-winning projects like River's Edge, at the University of Tasmania in Veresk, which is the case study she'll be presenting to us today. She leads Wardle's climate active agenda and contributes nationally via our committee, advancing sustainable practice through design, research, education, and industry advocacy. So I'll now start my formal part. So give me 1 second while I share my screen. Hopefully that will all work. Share screen, and that's my screen. I hope everyone can now see that, and I go to presentation mode. Right, I hope that's all working. Yes, again, my colleague Government Architecture is telling me it's all working. Fantastic. So I'll go through the advocacy part. Alison will go through the playbook part, and then Alex will go through the case study of the University of Tasmania, after which we have questions and discussion. Just before I start, an acknowledgement of all the contributors to the decarbonisation plan in today's session. I want to highlight, apart from Alison and Alex, of course, my co-chair, Caroline Pitcock, but also Jane Cassidy, the immediate past president, who was the absolute champion for this piece of work and socialized it with the building ministers forum end of last year. The QR code, we'll show it again at the end, is a link to the actual plan, but you can also just Google it. So just a little bit of background. In late last year, we first produced the decarbonisation plan advocacy summary, which was a short version, only the advocacy chapter. And that the purpose of that was to translate science, the science that we all know about of the IPCC, the International Panel of Climate Change, and the International Energy Agency, into the trajectory that buildings have to be on if we want to hit net zero by 2050. We then, that was socialized with the Building Ministers Forum. We then expanded on the document to create a resource for members, that's for you, that not only talks about the science and advocacy, but then gives hopefully practical guidance on through the playbook of what architects can do in their own right, and talks about what the Institute is doing itself to support the agenda through its own carbon neutrality, but also through education. Generally, the purpose of our work at NCASC is very much to inform the National Council of the Institute of Architects, to advocate and to educate. So hopefully you find this session useful. So part one of the document is advocacy. So I'll start with very briefly the science. It gets a bit technical, but then Alison and Alex will make it more digestible as we go forward. So globally, buildings contribute to about a third of carbon emissions. As you can see here, the majority currently of that is operational emissions of the operation of buildings, and about 7% from production and construction. However, as our electricity grid decarbonizes, the proportion of the embodied emissions, which sits in this red section, which will relatively increase. And we'll come back to that. That's really important in terms of the opportunity for architects. But let's stay with operational energy for now. The International Energy Agency states that to achieve net zero by 2050, this is global net zero of everything, all new buildings need to be net zero by 2030. That's only 5 years away. So that's a significant leap from less than 5% of new buildings doing that today. So in other words, within 5 years, we have to go from business as usual today to every new building globally to be net zero. A net zero operational energy building is a highly efficient all-electric building that is grid responsive as well, so it can help the grid transition and is powered by renewable energy. We have then translated this into a policy advocacy table, if you like, a timeline on which we map, first of all, those international science targets, and then of 2030, 2040, 2050. And then we translate that into what we should all be doing. So just to reiterate this, 2050 is the target, absolute net zero, 2050 globally. So the International Energy Agency is telling us 2030, all new buildings have to be net zero operational carbon. And by 2040, all buildings, including all existing buildings, have to be net zero operational carbon. That means no direct emissions from the buildings on site, but also no scope 2 emissions. That means no emissions via the power that these buildings use. That's the science on operational. So we translated that into what policy should be in place in Australia, starting with a 2050 overall target. very clearly, and the Victorian government, I'm proud to say, being a Victorian government employee, has a very strong agenda on exit out of gas for buildings. So clearly, for two reasons. A, this is a dying technology, if you like, in buildings because we need gas to support other industries, manufacturing, travel, and so on. But the other reason is that to get to the net zero operational target, we need all buildings to be grid responsive. So as of today, as of now, and as you build buildings that are actually might be completed only in 2030, we need to have no fossil fuels in any building today. There are some building types like hospitals that might be a bit tricky for now, but even there we are seeing the first all-electric hospitals. So no fossil fuel today in any buildings. By 2030, we need them all to be absolutely operationally net zero. That also means powered by renewable energy, 100%. To get to 2030, we have to update the National Construction Code 2028. Now, I will make some notes about this week's discussion around the productivity roundtable and how that might affect that agenda. 2040 then is all buildings. That means there's a lot of work in the upgrade of existing buildings, and that includes taking all gas, all fossil fuels out of those buildings, replacing. But of course, for architects, the opportunity is to not just do a services upgrade, but hopefully to improve the envelope and the performance of buildings as well. So hopefully there's the opportunity for architects to engage their clients in more than just services replacement. That's just the overview of that. Just to mention that Victoria itself has an earlier total net zero target of 2045. And that's the reason why we are advocating for 2040 to be really our target on net zero. That was operational emissions. Now let's talk about embodied carbon. Again, the end goal is clear, but how do we get there? We now have nationally agreed tools for how we measure embodied carbon. Today, a new building that's being built will typically have half of its emission in embodied carbon and half of its life cycle emissions in operational carbon. But as the grid decarbonizes, that the embodied carbon part will increase, which means architects, as the designers and specifiers, along with engineers, have the greatest opportunity to reduce carbon in new buildings. Because we now have a new nationally agreed tool, which is called Neighbours Embodied Carbon, we should all strive to do the basics and at least get to a 4-star minimum embodied carbon rating. We've put government procurement here as a leader. Then basically it's a journey from there to zero by 40% by 2030 and then 100% by 2040. That's a very ambitious target. It's a difficult target. But once you see what we're doing and then assuming that the manufacturing industry will decarbonize itself, that's a journey. So just to summarize, use Neighbours Embodied Carbon from today, try to get to 4-star minimum. Importantly, Neighbours Embodied Carbon only measures the product and construction stage, not full life cycle. And at the moment, only structure, services, and facade. So working with those disciplines will be critical. These are the, I promised you it would be very technical, but we'll have much nicer slides coming up. So just to be a bit technical, a 4-star neighbors rating, embodied carbon, means the equivalent of a 22% reduction, or say round about a 20% reduction of embodied carbon versus business as usual. Sounds easy, is actually harder than you think, but that's what we should be doing right now in every architecture practice on every project. So with that, what do we do now? I said I would do some notes. There's, as you might have heard, there's tremendous pressure on the National Construction Code. It is seen by some as a productivity hinderer. So this week, literally, the productivity roundtable run by the Commonwealth is investigating whether the NCC should actually be continued in its current form as we know it. So that trajectory that we advocated for may be a bit in the air. So in other words, we cannot really wait for regulation. to do its part. My understanding is that NCC as a whole may be reviewed as a document and how it regulates, but we clearly have to act now. And on that note, I'm handing over to my colleague Alison on this very slide, who will run us through the playbook of the plan, which is the guidance of what architects can do now.
Excellent. Thanks, Stefan. And bear with me while I bring up my screen. Okay. So can everyone see my screen there?
Yes.
Yes. Great. Excellent. Hello, everyone, and thank you for joining. I'm also speaking from the lands of the Wurundjeri Woi-wurrung people, and I'd also like to acknowledge their enduring connection to land, waters, and community, and pay my respects to elders past and present. I also extend that respect to any Aboriginal and Torres Strait Islander people with us today. I'm going to walk you through the part 2 of the Australian Institute of Architects Decarbonisation Plan, the Future Practice Playbook. This playbook is part of the broader decarbonisation framework, and it is designed as a practical toolkit for firms of all sizes, from sole traders to large multidisciplinary studios. It applies across all building types, residential, commercial, institutional, and beyond. It is not a policy document, it's a guide that shows us really what any practice can do right now to work towards this decarbonisation. And importantly, it frames sustainability not only as a responsibility, but as a business opportunity. It is intended as a living resource, continuously updated with new stories, tools, and shared knowledge from across the profession. Yep. Sorry, just having a little delay with my slides here. Seems that the technical challenges are following me. Okay. Can everyone see that slide, Ange?
Yes, we can. Thank you.
Great. So as architects, we're in a unique position. We don't just design buildings, but we also shape the way that people live, connect, and care for the planet. The playbook really attempts to recognise this. It's not about ticking boxes or compliance. It's about staying relevant and preparing for the future of practice. And across Australia, we're already seeing really inspiring leadership. Big firms, small studios, many of us are really finding new ways to reduce carbon and rethink design. What the playbook offers is a shared platform to learn from each other, to spark innovation, and really importantly, to create a common language for climate action, clear metrics, open conversations, and a shared ambition of how we'll be able to track our progress and move forward together. So ultimately, this is about architects leading the way, not just as designers, but as change makers. We know the urgency, climate change, rapid urbanisation, and shifting client expectations, meaning that sustainability is not really optional. As we sort of acknowledge, architects are well placed to lead this transformation because our influence really spans the entire process, from setting briefs that prioritise sustainability to specifying low carbon systems and materials to optimising performance with passive design and renewables, and to shaping greener and more resilient communities. And the business case is strong. Good design drives economic value through lower operational costs and enabling access to green finance. It reduces emissions and enhances biodiversity. And it delivers healthier, more equitable spaces for people. So to stay relevant within this rapidly shifting industry, we need to rethink how we embed sustainability in our practice culture, use digital tools to track impact, and better align with the goals and the needs of our clients and communities. But I believe collectively we do have the creativity, the influence, and the tools to design not only sustainable buildings, but sustainable business models. So one of the first challenges is clarity, and that I think was very clearly highlighted by Stefan earlier. But really fundamentally, what do we mean by net zero, carbon neutral, or climate positive? So the playbook helps us navigate these definitions and align them with phases of the decarbonisation trajectory. For those who haven't yet, I strongly recommend exploring the Embodied Carbon Curriculum, which is available on the Institute's website. It's a really excellent foundation in terminology, measurement, and practical application. The Institute is really focused on supporting the whole profession, not just large firms who may be really already active in this space and have systems in place, but smaller practices who need clear, accessible pathways. Rather than thinking about the never-ending list of tools and compliance standards out there, I thought it's helpful first to understand our carbon impact in two really clear ways. The first is our practice operations. So this is how we run our studios day to day and take accountability as organisations. Becoming carbon neutral certified is one way that your practices can demonstrate that we have our own houses in order. Architects Declare have excellent templates for setting up your sustainability action plans, and B Corp provides global recognition of your practices' commitments to high social and environmental standards. The second, and where we have the most impact, is through our design services. This is where energy modelling, embodied carbon assessment, and circularity strategies come into play. Whilst these typically sit in our sort of effectively scope 3 kind of emissions, and often owned by our clients, so to speak, they really do represent the greatest opportunity to reduce carbon at scale. So we really encourage practices here to create systems enabling them to track their own scope 3 influence emissions as a way of being able to demonstrate how they offer value back to their client, as well as being able to track and showcase your achievements. So here is a super simplified roadmap of that decarbonisation journey that Stefan talked you through earlier, where we are now and where we need to be by 2050. And so it really visualises the steps around reducing operational carbon and how we move from, how we approach our new buildings, and then over time, effectively adapting all of our existing buildings to reach a kind of complete retrofit of our cities. It visualises also the steps to tackle embodied carbon and the way that we start to consider whole of life carbon and climate positive outcomes as we transition. But, I think it's really important, I would say, to kind of clarify, I guess, that decarbonisation really isn't a single action or implementation of technology. It really is the mindset that we embed from the very beginning of the project. So as architects, our greatest influence lies in the earliest decisions we can make, questioning whether to build at all, reusing what already exists, and choosing materials that support circularity and long-term value. So these choices, form, site orientation, and structure, can lock in the biggest carbon impacts before sketch is even drawn. As the project progresses, opportunities for deep carbon reductions narrow. That's why we set whole of life carbon goals from the very first briefing and guide each stage with tools like carbon assessments and performance modelling. But our role always does go beyond reducing harm. Regenerative design challenges us to restore ecosystems, support biodiversity, conserve water, and integrate renewable energy. Circular thinking ensures that we are designing for reuse and recovery, and we design out the very concept of waste. So at the heart of it all is really how we come together in a human-centric idea of sustainability being also ethical and equitable, how it can support well-being and fairness in everything that we create. So it's really when we combine these principles, early intervention, regeneration, circularity, and care, that we can really truly unlock this pathway to climate positive design. So one of the first case studies we highlighted is Sydney's Q Quarter Tower by 3XN and BVN, which is the global benchmark for radical reuse. So instead of demolishing the existing building, the design team retained 65% of the existing structure and over 98% of the core. And that decision alone saved more than 12,000 tonnes of embodied carbon in concrete. The redevelopment doubled the floor area and occupancy, And through some clever design and engineering, it became the world's tallest upcycled skyscraper. Its vertical village concept, stack volumes, central atria, and interconnecting staircases reinvents high-rise design for social connection and daylight amenity. So this project showcases how radical reuse delivers massive carbon savings whilst achieving world-class design and recognition. Our ladies, their workplace is another really powerful example going beyond carbon. So Waterbrook, working in close collaboration with engineer client Arup and builder Shape, could take a regenerative approach guided by the Living Building Challenge for this project. So this project prioritised circularity using salvage timber, upcycled cladding, and red list-free materials to enable the diversion of over 90% of construction waste from landfill and achieving upfront emissions around a third lower than typical benchmarks. Arup also committed to renewable energy offsetting all upfront emissions and are currently in the process of ILFI certification for the project. So again, this project demonstrates how regenerative design can be embedded even in small projects through material choices and really the culture of the team and how they collaborated together. At a residential scale, Suppling House by Anderson Architecture is a Passive House Premium certified home that achieves a carbon negative outcome, considering both embodied and operational carbon, generates more energy than it consumes, and it uses renewable, reclaimed and recyclable materials. More than just a sustainable house, it is designed for well-being, with stable indoor environments, acoustic comfort, and flexible family spaces. Suppling demonstrates how a single home can be both climate positive and life enhancing. And Fund House by ASA is a compact urban infill project on a 170 square metre site built to Passive House standards. It includes 2 dwellings housing 6 people arranged around a central courtyard, which bring daylight, ventilation and social connection to a dense urban context. And it really demonstrates how small, clever design can deliver low carbon living with high amenity, and that sustainability is possible even on tight sites with limited budgets. So what can we do as practices and as individuals? So the playbook outlines 11 key actions. So starting with leading by example, so making your practice carbon neutral, appointing a sustainability leader in your team to guide and grow the business, setting ambitious goals early with clients and with builders, and interrogating the brief. How can you build less and reuse more? Designing from first principles and really designing to climate with passive design and efficient systems. And embedding sustainability into your existing workflows and not trying to reinvent the wheel with every last thing. So making low carbon materials and sustainable materials in your default spec. So making that your norm. And electrifying buildings and phasing out fossil fuels. Verifying your findings with third-party assessments or independent assessments. And measuring your progress at each project stage. Find out what worked, what didn't work, and hopefully do it better next time. And most importantly, celebrating and sharing your successes. Finally, I'll start with some clear next steps for all of us. It is around upskilling our teams and really continuing our training within carbon literacy, life cycle carbon analysis and sustainable design. It's about being able to measure and set targets early, making sure we can target achievable reductions in embodied and operational carbon at the very outset of the project. Integrating passive design, so optimizing the size, the shape, the orientation, daylighting and ventilation. Specifying low carbon materials and systems, considering retained or salvaged materials, local sourcing, timber, low carbon concrete and steel, and renewables. And engaging clients, really making decarbonisation part of the brief from the outset. So if we commit to these steps, we not only can align with the decarbonisation plan, but we can also position our profession as leaders in shaping a resilient, regenerative future. So the playbook really is here to guide us, but the real change comes from all of us. How we design, how we run our businesses, and how we collaborate as a profession. And I think together we can transform our industry into one that is carbon neutral, regenerative, and future ready. So thank you. And I'll now pass over to Alex from Wardle to expand on one of the other really inspiring case studies from the decarbonisation plan.
Thank you, Alison. And just a quick note for everyone, you can start popping your questions into the question and answer box. I will then review it, and it looks like I also MC the question and answers. Over to you, Alex.
Thanks, Stefan. Thanks, Alison. Okay, let me just get my presentation up. Can everybody see that?
Yes, we can.
Okay. Okay, thanks for that introduction, and it's good to be here. Before I start, I'd like to respectfully acknowledge the traditional owners and custodians of land upon which the projects I'm going to present to you today were realised, as the Palawa people of Lutruwita. UTAS, the University of Tasmania, undertook a significant infrastructure project which involved relocating their Launceston campus from Newnham closer into the city to this site of Inversk. And the goal of doing so was to merge education with the local community and its infrastructure there, and really to make education more accessible for all Tasmanians. In 2018, Wardle were then commissioned by the university to design 3 buildings, 2 in the site of Inversk and 1 across the river that was linked to the site with a new bridge. These 3 buildings really were to demonstrate a visionary commitment to low carbon design, and it was led by a forward-thinking vice chancellor by the name of Rufus Black. 2 of the 3 buildings achieved over 30% reduction in upfront embodied carbon, and that was compared to a reference building of the time. And today I'll be sharing our holistic approach to achieving these carbon reduction targets by using one of the case studies, River's Edge, which was a learning and teaching building completed in 2023. So here I'll take you to the site of Inversk. It is a place of many layers of cultural significance. It's a historic railway yard, which also holds Indigenous cultural significance. And it's been used as a sporting and arts, tertiary education and recreational precinct for the people of Launceston. Its position, you can see, is nestled into this bend of the North Esk River, which sits on the periphery of the city, which is to the top left of the page. The site has this legacy of industrial architecture of the 19th century railway industry. So for us, it was important to consider the built form and the character of these university buildings. We did ask ourselves, how do you reinvent the identity of a new university that's effectively scattered within an existing precinct of heritage buildings and non-university functions? And importantly, what does that look like? I guess our starting point was to draw upon the evolution of archetypes already within the precinct. Here, the long extruded gable forms of railway workshop buildings built in the late 19th to early 20th century, coupled with the large square footprint of the sawtooth roof forms that were built in the early to mid 20th century. These structures were built in a high carbon era and they were scaled for industrial production. Projecting forward, though, to a low carbon future of the 21st century, the 3 new building designs were to represent a contemporary style, and they take on these hybrid forms within the heritage precinct. Each one adapted and responded to their unique site conditions, which were often infill sites with awkward site forms. And it is through this new architectural language that the university can then emerge from its industrial setting and promote this low carbon future. And here, the built outcome of the River's Edge Learning and Teaching building. You see the 4-pane window looking down Traversa Lane, which acts as this navigational marker and offers a glimpse inside the new function of the precinct. And it does put education and learning on show. And here, the building shifting silhouettes. They provide different vantage points from within the precinct, which add intrigue, and they also draw the passerby in. Inverted sawtooth roofs here have been scaled for habitation as they become window portals. And the window portals direct deep views outwards to the surrounding hills beyond the river. And here, revealing itself fully along the North Esk River with full panoramic shaded glazing windows. You can see now the building really asserts itself with this new identity, and it projects this idea of a learning institution that's kind of revitalised the former industrial precinct and brought it into a new low-carbon 21st century. Hydro, to give you a bit of context, the story about hydro has really shaped a Tasmanian identity, and today it's this legacy that really gives Tasmania a distinct advantage over the other states in Australia. It's powered substantially by a renewable hydroelectricity, and having a clean energy profile then shifts the focus of building design in Tasmania. So with operational emissions being low as a starting point, we found that the University of Tasmania could then prioritise reducing embodied carbon. So it's really a great example of how state policy and energy profiles can actively shape how we approach design. They can also inform the clients and influence sustainable outcomes. To put this into context with the university building, however, we looked at the life cycle analysis of a generic education building in Victoria versus Tasmania, and it quickly showed us how ahead of the game Tasmania is from an operational carbon perspective. The operational carbon emissions you can see here of an education building in Tasmania are currently 60% lower than that of a comparable building in the mainland, and that's because of its renewable energy resource. This coupled with UTAS's carbon neutral accreditation status, so as an organisation which actively measures and offsets the operational carbon from its assets, the baseline for all the new buildings for UTAS was set at net zero operational emissions. So this then pushed the conversation forward, and it was beyond just managing energy use to something more like considering embodied carbon and the design choices that lower emissions from day one of building design. It was from this point that ambitious targets of 30% reduction in embodied carbon were set under the stewardship of Vice-Chancellor Rufus Black. So how did we approach these ambitious targets? Our first step was to quantify and to develop systems that isolate and measure materials, which becomes quite crucial. And we found Revit to be a useful tool for this assessment. But by measuring, we quickly started to understand where the greatest impact of our materials choices were coming from. And evidently that's in the superstructure, facades and foundations. And these are the areas where you can also find the biggest opportunities for carbon reductions. The next important step, we'd say, is to conduct a materials research exercise and to track the information. Developing a process that really allows for early adoption of materials research and tracking of the whole life carbon factors of our materials choices really is critical. And to do this, we used or adopted a materials matrix, we're calling it. And this allowed us to input our research on materials, compare the pros and cons of all the relevant factors, so not just carbon as a factor. And this information was then used to inform our material selections, as well as feedback directly into our design decisions. The ESD engineer then helped manage the process with all the data and information. They took the material selections and our quantitative takeoffs, and they put it into a life cycle assessment it could then start our comparative assessment of embodied carbon on the project. And it's through the life cycle assessment reporting that we found the process to be one of continuous review and reassessment across all the phases of design and construction. And this is critical to ensuring that your carbon savings are incorporated for the whole length of the project. We also found that the process required a much higher level of earlier consultant coordination and also an earlier contractor collaboration process. For example, we held workshops with the civil and structural engineers during the design phase to optimise the structural design to see if we could incorporate savings through design in that way. And we also ran an early contractor involvement phase before the construction phase, and this was to assess procurement issues and seek industry feedback as an additional check on our own research on materials. But through this process and having all this technical data, we actually found new ways to innovate with materials. For example, this typically used for large spanning roofs, this Aramax aluminium sheet profile was used instead as a monolithic cladding system. It was informed by our design. The material reflects the industrial character of the historic Inveresk site, but it was also chosen for its durable, low maintenance, economic and local manufacturing benefits as well. We were initially sceptical of the carbon footprint of aluminium, but the product is absurdly paper thin. It's only 1.2 mil thick, and its profile, which is designed with structural spanning capacity, actually attributed to less secondary steel framing than a conventional steel-clad building. And as a result, the carbon assessment really revealed a much smaller upfront impact, and it allowed us to reconsider the product based on its whole of life carbon benefits. So an interesting study. The process also allowed for project-wide collaboration and interesting solutions to be discovered. For example, here, the UTAS project managers went out and found and secured and supplied the contractor with disused steel gas pipelines from Queensland. And these were used as foundation piles for 2 of the 3 buildings. This is pretty significant because the buildings are really designed in a swamp-like condition. And this meant that 77 concrete piles that required to be 18 metres long could effectively be substituted with these repurposed gas piles. And they contributed to significant carbon savings. Then there were instances where material substitutions probably didn't go as planned during the construction phase. Low carbon Invisia concrete contributed to the most carbon reductions on the project, as it was used for the superstructure of all the floors and the columns, and attributed to almost 14% savings. But we did run into trouble during the construction phase when Boral released their ready-mix concrete EPDs for Tasmania. And they actually showed less carbon reduction savings than previously advised during the design phase. So we had to engage directly with Boral to sort of understand why this was the case. They explained that they use the concrete mix, they use different concrete mixes for winter and summer in Tasmania, and this was to deal with the different ambient temperatures affecting curing times and workability. So we then had to work with the contractor to understand construction sequencing and understand when the winter mix would come into play. And after a reassessment of the life cycle analysis with the consultant team, fortunately, the project was still able to meet its embodied carbon targets by using 32% of a winter mix in the end. Industry-wide collaboration and finding local solutions was quite pivotal to this project because it was funded by government. We engaged with local suppliers and manufacturers directly in the Tasmanian timber industry to find local manufactured solutions for the CLT stair, for instance, and for all interiors and timber-lined floors, ceilings and walls, and also joinery installations. And here just some images of the interiors. You can see the warm timber-lined atrium, which really contributes to the overall spatial experience of the interiors. Combined with the hanging coffers, it also provides this sort of unexpected contrast to that industrial exterior shell that helps to draw the eye upwards on arrival. And here again, across layers of activated timber edge conditions, which were study spaces for the students on the atrium edge, and the deep coffers on the right there that were used also to soften the light in the atrium. And then on our materials research journey, we stumbled across some local solutions with low carbon benefits. Here we sourced carbon neutral bricks from Austral Bricks Longford plant, and they were used to articulate these curved learning and teaching pods on the ground floor. Austral Bricks was the first brick manufacturing plant to achieve carbon neutral status, and it does so in part by using sawdust waste from the local Tasmanian timber industry, and they use that as biofuel. The subsequent carbon assessment for the brick revealed some surprising results, and it's compelled us to actually make some design changes as a result of having this data and this information, this technical data and information. We realised the specification of carbon neutral bricks exposed the impact of the cement mortar joints in bricklaying. So the original design intent was to actually incorporate this thickened slopped mortar joint with up to 32 mil wide joints. But after revealing the impact of this upfront embodied carbon, we then reduced it to a standard 10 mil joint. So these were just a few stories and lessons learned from our embodied carbon journey, I guess you could say, on these projects. But we can attribute the overall success of the projects on having a team that was working towards some common values. First one being stewardship from a forward-thinking client. They did set a really ambitious goal, but they also gave the project team agency to innovate, and they backed non-conventional approaches. Secondly, there was also a very systematic approach to decarbonisation through design, and this was adopted by the whole project team. And finally, there was this shared commitment across the project team and the construction team towards achieving the project's ambitious sustainability objectives, as well as achieving design excellence in that outcome as well. So that was it for me. Thank you.
Fantastic, Alex. I can hear the buzz somewhere in the universe. That's fantastic. We're even on time, surprisingly, despite the technical difficulties. And we'll now get on with some questions and answers. I'll kick us off, and maybe you can, unshare. Alison, if you could turn your camera on, that would be fabulous. Thank you so much. So Alison, Alex had a fantastic client, right? The client as a champion, as we all love to have them. What can architects do to influence clients who are not quite there or who don't know what they're missing?
I think that's a really great question, and it's something that I think we all come across every day, in our projects. And I would say that being able to highlight the benefit back. And I think that's something that we really wanted to focus on in the decarb plan. We're just being able to, I guess, part of the importance of sharing these case study projects across all scales and all typologies is that it's really about the process. So, I guess it's something, we have to acknowledge that some buildings, as you mentioned, are going to be more challenging to decarbonise, and we're going to have different levels of influence on. But I would say being upfront and really having those conversations early is really critical to kind of finding the opportunities that resonate with the client. So it's really what value they have, what are their drivers, really being able to find and have that conversation around aligning, some of those fundamental core drivers of the project. But I would say also there's a lot to do with passive design.
Thanks, Alison. Alex, do you have anything to contribute to that? What do you do? How do you take the learnings from this project with your ideal client to projects where they may not be the champion yet on the client side?
Yeah, it's a good question. We've certainly learned a lot from these projects and implemented some of the systematic approaches into all of our projects where we can. It's a difficult one, and there's variation for sure across projects. But there's a lot we can do on our own accord, and we've learned from that process. And I think by undertaking the task even of measuring materials research, doing your own materials research, talking with industry and talking with contractors, you do learn a lot that you can then implement into other projects. But you just need to do it once, I kind of say. And once you've done it once, you take that off and just use it as a first principles approach almost to designing. So I think what Alison said there is the processes are important, but attacking it from first principles and embedding some of your own research and knowledge into the next project moving forward.
So in other words, when I outlined the science and where we have to head as an industry, what you're saying is that architects need to upskill once properly.
Yes.
And any tips from either of you on how to do that internally within your practice?
So I think I think that the conversation is really important, and creating a shared goal. So I think those sort of 11 steps we highlighted, I think, are really fundamental. And it really does start with getting your own house in order. So once you've understood what it takes to transition your own organisation, then it's much easier to relate to the needs of your clients and your end users. So I do think there's a kind of initial step around just checking in with what why we're here and what we try to do every day. But I also think it is about, first step is measuring what your impact is. So I think HDR is a global organisation. Actually, they do a lot of very high load types of buildings. So it is a challenging journey to really kind of achieve some of the reductions in embodied carbon in very high loads and in operational carbon in really high load buildings. But I think the first step is really acknowledging it and then really just applying that thinking as best you can. So again, just reiterating that kind of first principles approach to every project.
Thanks, Alison. And I would say that there are a lot of people with goodwill, such as yourselves, to give up their own time, share the lessons, and so on. We had a question from Caroline Pitcock, who is asking, Alex, how long has your practice, Wardle, been on this journey? I guess there's yourself, you've been on the journey, and Wardle. How long has Wardle been on the journey?
Yeah, it's a long journey. It's an evolving journey. It's good. We've had a sustainability team, I think, since 2018, 2017 probably started up. So we're quite fortunate in that we have had some internal interest, and that has led to having a team, and that does evolve into being able to do some research and also to bring the information learned into the practice and hopefully across all projects. It's not an easy exercise, but we do have sort of processes now in place to help roll that out across. So I guess the learnings from all these, but we're basically, like everyone, learning from each project and pushing it forward onto the next, hopefully. But we self-educate. We've got the team going out and bringing that information back and educating. But as Alison said, it's really the project work you do, the best case studies for learning on. You can bring, besides measuring, understanding how structure plays a role and the impact you can have there. bringing your own materials research library into play, educating people that way. But yes, it's an evolving beast. So we've been on a long journey, but each project is a next learning opportunity we see, and we just try and build on that knowledge. Yes.
Thank you so much. And surprisingly, with that, we're already at the end of our time, unfortunately. And fortunately, the good news is this is only the first session of many that we'll put on as a committee. We will have sessions on which tools to use. We will have sessions on materials with Lauren Howe from Arab. Tools will probably be David Ritter from Grimshaw. We'll have a session on harvesting products and materials out of existing buildings with Carolina Beckman from GXN, the research arm of 3XN, the company that did the building that Alison showed. So a lot of really exciting how-to and inspirational projects coming up. With that, I need to draw the session to a close. I would really love to thank Alison and Alex for their fantastic work, giving up their time to not just do the work at the committee, but also to prepare this. And I would like to thank everyone for joining. Just a reminder that the lean-ins are recorded. Please share them widely with your colleagues and beyond. And you can also receive notifications of when new lean-ins are available to view. And find by subscribing to the Australian Institute of Architects YouTube channel, which is YouTube at Oz Architects. With that, thank you so much, and enjoy the rest of the day.
Thanks, Stefan. Thanks, everyone.
Bye.